welcome to my talk. Before I start, I would like to thank the organizers of UXDX for organizing an awesome conference. And I would like to thank you for attending my talk. I hope you really enjoy it. So the talk is becoming a high-performance organization, which is a relatively large subject. So what we're going to be showing here is just the top tips. Before I start, I'd like to mention the incentives behind this presentation. When I joined Parcel Vision some years ago now, the idea was that I would join as a tech lead and an architect. And I found out that while I knew a lot about that part, I didn't know a lot about being the head of engineering that I ended up becoming. The problem was that while there is a lot of information about distinct subjects that relate to this, there isn't actually any body of knowledge around how to bring them together. So there is no way to learn actually what to do from start to finish in order to become a high-performance organization. Just a sequence of tips here and there, and not all of them work together. So I've been working for the past year or so trying to come up with a framework that allows you to become a high-performance organization by bringing together all of the different aspects that work combined to help you. This is going to be what I'm going to be covering in this talk. And without further ado, let's kick off. So what is a high-performance organization? In my words, a high-performance organization is a learning organization which relentlessly delivers value to its customers. There's a lot of it there, so let's try to unpack some of it. So before defining and seeing the relationship of everything, I think it's useful to convey the message through some examples. So what's the difference between high performance and low performers? High performers are in fact orders of magnitude more able to deliver code to production and value to their customers than low performance. Of course, here we're speaking about operational performance, but still, as we will see later, this is quite important because this is your ability to deliver value to your customers. And seeing just the numbers here, there is a huge gap between those high performance and low performance. We're talking about 170 times faster to recover from downtime. A high performer is down for a minute, a low performer is down for 3 hours. That is quite telling of the difference. Operational performance, however, is not just important for that aspect. It's important for organizational performance as well. So the State of DevOps report of 2014 hinted at this, and I'm quoting, strong IT performance is a competitive advantage. Firms with high-performing IT organizations were twice as likely to exceed their profitability, market share, and productivity goals. But while State of DevOps alluded to this, the Accelerate book that came out in 2018 actually proved this conclusively. There is scientific research within done for Accelerate, and scientific research you can find out about exactly how they calculated these things. But they proved that there is a causal relationship between software delivery performance, so your operational performance, and how your organization performs. So when we say about organizational performance, we really mean about basically money that you're gaining, and also non-commercial performance. What's our experience? When I started working with Parcel Vision, I wouldn't necessarily say that we were a traditional enterprise environment, but we still didn't fall in the high performance description of the State of DevOps. We released once or twice per sprint. Work lead time, so the time from a feature being requested to being deployed in production was 3 to 4 weeks. And deployment lead time, so code committed to a repository until code is running on production, was in the magnitude of days. Now, after implementing this framework, we are seeing that we're deploying 10 times per day. The work lead time dropped from weeks to days, and the deployment lead times is around 15 minutes. So how do you achieve that? The 6 top tips to achieve that operational performance to help you then achieve organizational performance. Tip number 1, avoid monoliths. So when I say avoid monoliths, I do not refer to a modular monolith. A modular monolith is okay. A modular monolith, if it fits your non-functional requirements, is something that is not something to avoid. But on the other hand, traditional monoliths and distributed monoliths are 2 very bad situations to be in, because it impacts your ability to deliver changes drastically. And it makes additional work need to take disproportionately longer amount of time to actually do. So how do we tackle this? There is 3 tips that I would like to mention here. So first of all is domain-driven design, the strategic patterns. So domain-driven design is a set of patterns that you can apply in your domain model and architecture, which is what we refer as a set of strategic patterns, but in some patterns that you can apply in code to better meet some of the requirements that you have, which are the tactical patterns. So part of the strategic patterns that apply in this particular situation is the concept of bounded contexts. So bounded contexts are, in essence, boundary around functionality that helps make sure that we're encapsulating complexity and don't let it seep through to other services. And you will notice that we're aligning those bounded contexts through, with business domains and subdomains. So we'll notice that you will have, if you have a shipping functionality within your business, you will discover that you have a shipping bounded context. It may be important to you, it may be not, but there will be some there, and there is a boundary around that, and that helps modularizing that that complexity. On top of the bounded context, we have context mapping, which is relatively new. So domain-driven design exists now for something around 20 years. So context mapping is much more newer. Context mapping builds on top of bounded contexts and helps you identify what kind of relationships do those bounded contexts inherently have. Modeling the relationship correctly will help you make sure that you don't have a disconnect and also you don't have increased kind of coupling between your services. So this will be stuff like a shared data model, if there is indeed a shared data model between the services. So it's like a user, for example. There is a user model across many services, recognizing what kind of relationship. So is the user owned by a specific bound context and shared in some cases. So the model itself, not necessarily, I'm not speaking about sharing the database, but the model itself. How does that get shared across is quite useful. And the final tip for this is the use of event storming. Event storming is a collaborative exercise to create a domain model along with your domain experts. Event storming helps you avoid monoliths by making the bounded contexts, the boundaries of functionality very visible. There are a lot of tools. There is a good book that you can read to learn about event storming specifically, and how does that relate to coming up with useful and meaningful bounded context boundaries. And before I move forward, I would like to mention this quote from Alberto Brandolini, the creator of event storming. So quoting, "It is not the domain expert's knowledge that goes into production. It is the developer's assumption of that knowledge that goes into production." And event storming really helps with that. It helps transfer and convey that knowledge across everybody. And it helps reach a shared understanding of what we're going to be building and what is going to be running in production. And again, this is very useful because we are going to be modeling. So the idea of the bounded context is we're going to be creating boundaries around what the domain experts think of as domains and functionality. So having that here is really, really important and really helps a lot. Tip number 2 is less obvious. It's just basically avoid the impedance between your persistence model, so the shape of the data as stored in your database, and your domain model, which is the shape of your entities when in business code, when you are running your business logic. One tip that helps here, basically the solution to this problem is to use event sourcing. So event sourcing is a persistence pattern that basically stores a particular entity not as a document or as tables in a SQL database or a normal form database, but instead as a sequence of changes, domain-specific changes that have happened over that entity. This is actually quite powerful because you will notice as you maintain your solution that your domain model changes to support new functionality, but your persistence model is not. So your persistent model, if you're using a document database, your persistent model is what used to support your previous domain model, but it doesn't necessarily has all of the data to support your current one. And especially with document databases, it may be quite complicated to actually restructure that information. With normal form database, again, there is the same kind of problems. So you have data stored in specific structures and relationships, but they don't necessarily map well with your domain model. And this impedance can impact your ability to deliver work. And it also makes deployments quite difficult when you're introducing new functionality that needs the data there. Event sourcing guarantees that you have the information there, and also that you have the information in a way that is very slow changing, especially if you use event storming and event modeling to make sure that you capture those events as the domain experts recognize them. The chance that this change is really low. It does happen from time to time, so you will still need to understand and learn a new set of patterns that are necessary to support and maintain event sourcing in production. But from experience, I can tell you that it's actually quite easier to deliver changes in the domain model as in production using event sourcing rather than anything else. Tip number 3, reduce coupling. The best way to reduce coupling is to use event-driven architectures. Event-driven architectures, by their nature, exhibit low coupling, and they exhibit low coupling for multiple reasons. A topmost one is that because it's messaging, it doesn't get affected by temporal coupling. So if one of your services is down for whatever reason, the other one can still function, and when the service that was down comes up, then immediately it will start consuming stuff like it didn't happen at all. So this is really, really powerful. It's really powerful because also it means that you can be partially available to your users, or even entirely available if the service that got temporarily unavailable was internal in your system. People will be hitting the API, they will be getting accepted or okay, or however you're designing your system, and they will be happy knowing that what they did happened, and they wouldn't be noticing any unavailability at all. It's actually quite important with coupling, so event-driven architecture helps with reducing coupling as well, because it doesn't exhibit behavioral coupling either. And finally, it also helps with coupling from the perspective of the contracts. So usually, if you are using any synchronous forms of communication, your services depend on those contracts. And as you add behavior to those services, anything that depends on that will need to change. With event-driven architectures and messaging, the surface area gets vastly reduced. But on top of this, you can actually use shared nothing practices to make sure that that is even reduced even further. So shared nothing architectures will basically are when data gets into the system, they either get disseminated to any services that need them, so there isn't a need to communicate some of that data across, or once they come into the system, they are published, observed, and stored locally. And then again, when there is a functional workflow running, there isn't a need to transfer those models across. There is a big body of knowledge from reactive principles that you can tap into to help you design event-driven architectures that exhibit low coupling. And a final tip for this is to prefer choreography. So choreography is basically one of the approaches that you can implement a sequence of actions. So assume that we have a workflow of A, then B, then C, then D, and that's the workflow that needs to happen when a user tries to do something. A choreography will imply that A publishes the word changes, and then B observes that and do its own thing and declares the changes, so raises an event, and then C, and so on and so forth. In orchestration, which is the alternative, you will have a central actor owning that workflow. And so it will reach out to A and say, hey, do this. And then when A does it, it observes that change, and then it says, so B, it's your turn, do your thing, and so on and so forth. Choreography is better because it reduces the amount of coupling that exists. Orchestration, you have the central orchestrator that is coupled to everything. And then in turn, all of the independent parts that do stuff also depend on the orchestrator as well. So in choreography, this is becoming linear. There will obviously be situations where you will need to implement orchestration, especially in complex failure scenarios. So if you have certain conditions, whether you apply one or the other, one of two options in the response to something failing, that's an indication of where you will need to implement. But other than that, default to choreography because it helps reduce coupling. Another tip is one that is potentially a bit divisive, is have meaningful test coverage. So before I mention exactly how to do this, I would say that one thing that definitely helps a lot is the onion architecture. So the onion architecture is structuring your applications in layers with dependencies only pointing in. And also in the center of that onion architecture is the domain. And the domain is where your business logic lives, and it is entirely dependency free. It depends on nothing else other than itself. So how does this help us in test coverage? Well, this way we can have very quick feedback tests that hit the domain and do its job, and we can validate that domain quite quickly and get feedback about the behavior of the system that we are working on, very meaningful, very quickly before we even commit the code. Event sourcing helps in this regard as well, because it changes those tests in from whatever you needed to do. So setup of data, which you didn't know how you came up with that domain model feed like that. It changes it to, these are the previous decisions that we made. This is the request from the user that we need to do. And then you expect certain events coming out. So it's tested decisions to be made. So you are acting, you're providing decisions, past decisions, the action, and expecting a certain decision out. This is something your domain experts understand. So this is something that you can give to the domain expert, and they will tell you this makes sense or this does not. This also helps you having a meaningful test coverage from the perspective of, you don't test code that doesn't need to be tested. You don't test conditions that don't need to be tested. You don't need to guard against stuff that will never happen. It happens more often than you may think. Flip side of that, so in addition and complementing that, will be contract tests. So you are testing your domain quite nicely. A contract test will help you test the public data contracts of your service. So making sure that the data and events that you are raising out or any APIs that you have don't break during your implementation. This is very important feedback, especially in a microservices environment. But these are also tests that run very, very quickly and very efficiently give you back information about what you're doing. And then you will definitely have end-to-end tests. You should be having end-to-end tests, but keep them small, keep them to a small number. Do rely on observability, by the way. If you're having a microservices architecture, you will find out that testing all of the permutations of behavior of your system is going to take a very, very large number of end-to-end tests. And this will need a long time to build, a long time to maintain, but also it will explode the time necessary to build and deploy your service. So don't do that. Obviously, you need rock solid CI/CD to do that. Tip number 5, reduce development time dependencies. Development time dependencies are dependencies that are stopping you from doing your work. So you need team A to finish something in order for you, team B, to do something. Bounded contexts help again. So it helps similarly to how it avoided the monolithic applications. It helps you by making sure that behavior is encapsulated within a certain bounded context. So you are delivering features around shipping, you are touching this bounded context alone. You don't need data from other services, you don't need behavior from yet other services. All of it is encapsulated on that particular regard. And again, bounded contexts are the pattern that you use for this. Obviously, event storming and context mapping help you make sure that those boundaries are correct. Structure teams around those bounded contexts. So you have that behavior encapsulated there, structure your teams around that. So you don't need other teams to do that. Have one bounded context owned only by a single team. So of course a team can own more bounded contexts. If you have more bounded contexts than teams, you don't need to hire more people. But on the other hand, avoid situations where a bounded context is shared across. Have a single team owning those bounded contexts and establish those relationships with context mapping. Event-driven architectures helps as well by reducing coupling, as we explained earlier. So when you are doing a piece of work, any dependencies on that piece of work on the contract, they can still observe it by that and don't have a behavioral coupling. So the behavioral coupling is really the one that impacts development time dependencies. And as a final tip for this, make sure that the stable service is the one that owns that contract between those two services. So an example will be the email service. So you will then have the email service that sends notifications of things that have happened depend on 10 or 20 services that you have in your system, because as those changes, you need to keep maintaining that email service. Why would you want to do that? Expose a contract and have all of the other services depend on that contract. The email service is probably going to be stable because SMTP is an ancient protocol in IT regards. It hasn't changed for a long time. It's not going to change now. So definitely identify those mature domains and assign the contracts to them. Final tip, reduce rework and waste. So this is, all of the lessons here are basically lessons that came up and existed, and you can find a large body of knowledge from manufacturing. And I'll mention this as we go through the different tips. So tip number 1, adopt an improvement budget. So improvement budget is kind of similar to an error budget. An improvement budget means allocating a certain amount of time per week or whatever in improvement work. That will mean removing any technical debt that was introduced during previous weeks or previous work, making sure that you reduce coupling if you discovered that you introduced something without your knowledge, adding tests to help you, creating new tools to facilitate deployments and testing. All of those are improvement work. Make sure that you allocate some time to this. Cross-functional teams, and when I say cross-functional teams, I really mean not just front-end and server-side development. I mean literally everyone, subject matter experts, developers, UX, BAs, everyone, the business, all of them working together to deliver a product. This comes straight out of the concept of one-piece flow in manufacturing. So manufacturing is an ancient industry. We've been manufacturing stuff for hundreds of years now. And there is a large body of knowledge around how to make that efficient. And I know that we all like to think that we are thought workers and we are working on ideas and developing this, but in fact, we have very large similarities with manufacturing. We're still building a product and delivering it. We are even using the same terms. So this is one of the ways to make sure that you are reducing rework and waste by making sure that you're building the right thing and you are reducing the handovers that are required. So everyone needed is involved. So the work gets done then and there, and immediately it can get delivered to production. Using pull-based system, another thing yet again taken from manufacturing, and this helps guarantee that the team that is developing the product doesn't get interrupted and have to pay costs for context switching, but also it helps guarantee that you are doing a piece of work just when you need it, not before, not later. And finally, a tip to both reduce rework and waste is carefully consider the alternatives of any work that you're going to be doing. Make sure that what you're going to be building is what is actually needed and what is correct. If you're going to be integrating with a service, make sure that you checked all of the other services that provide similar products, and make sure that you make the right choice of given the requirements that you have. With that, that's my presentation. This is some of the reference material that I used to create this presentation. And thank you very much. You will be able to find the presentation, by the way, on my GitHub repo. And do follow me on Twitter if you have any questions. Thank you very much.